In this video, we are going to solve a lead code valid anagram problem. This problem is asked in many interviews. So the problem is uh, given to string s and t, return true if t is an anagram of s and false otherwise. So what is anagram? An anagram is a word or phrase formed by rearranging letters of a different word or phrase using all the original letters exactly once. So in this, if we understand it with example, so if input S is anagram and T is nagagram, so if you see it closely, all the letters which are there in S are present in T, and there is no extra characters which are not in S are there in T. So it is exactly same. So it will return true. And one very basic thing is the length of both the strings should be same. If it is not same, then there is a difference. Any character which is there uh, in S is not in T, or it is repeated more time if one of the string is larger than other. So it will return true. If we see example 2, input is S is rat and T is car. So R and A are same in car as well from rat, but in rat T is there, in car C, which doesn't match. So output will be false. So let's try to code it in C sharp, and I have already I'll paste the code here. This is the brute force approach, the beginner friendly. I'll tell you one more approach which will be more optimized. So here we have this inputs S and T. So first thing we'll check if their length is not equal. If the both the strings length is different, then it's false. There is no need to check any other thing because there will be any character which is repeated more time, or certainly there will be a character which is uh, not in one string and it is in another string. So in this approach, first what we'll do is we'll convert both the strings to character array. As you can see here, line number 6 and 7, I had converted S to S array, which is character array, and T into T array. And then I had sorted both the strings. So what will happen is if it's a valid anagram, all the sorted string will be exactly same. So in next loop, I'll just check uh, if the same position character in S is not is equal to true. If anything which is not is equal to true in the same position, then we'll return false. If it works correctly and all the strings are checked, then return true. So let's run it. So you can see all the tests are passing, but the problem with this approach is first we are sorting both the arrays. So array sorting will have its own complexity, and we are sorting two arrays and then we are running one for loop. So instead of that, we should come up with a better approach. So here I'll paste another solution which is a better. This solution complexity for sorting it is log n. So log n, and for comparison it is uh, big O of n. So it becomes n log n, which translates to uh, big O of n. and which is also not a bad solution in this case. So if I paste another solution, so for understanding this one goes slightly complicated, uh, but here in first check is the same. If the strings are not equal, then it is false. In this approach, we have taken a count array. It is an integer array which size is 26. So all the English alphabets. So 26 we have taken. And here what we'll do is we'll count each character with the position. So what we have done is for each character we are taking from the string and we are putting in position where that, say if it is A, then it is in 0th position. So what we are doing is each character we are subtracting it with A. So ASCII value of A will be taken here, and when we are subtracting, its ASCII value of that character is also taken. Say if it is A, so then A minus A is like whatever the value is, it will be a 0. So in 0th position, A will be there. Likewise, in position 1, B will be there. Position 2, C will be there. So likewise, all the alphabets from A to Z will be there. So once when we are running the loop for string S, we'll keep on increasing the count for every position. And when we are then we'll run the same loop with string T, and in this time we'll keep on decreasing. So if the same characters are here and the same number of them are there, say like in anagram there are three A's, so the counter of position 0 will be 3. So when we run it for t, that time also will be keep decreasing, so it will come to 0. So there should not be any value like a positive integer or even the negative integer. So with that it will be, so once both the counters we have run, we'll check if all the counts are 0. If any of the count is not 0, we'll return false. Otherwise, it will be true. So let's run this also. So in this, all the tests are passing, and in this case also, the complexity of the solution is big O of n, because we have the fixed number, like whatever the length of array is, the loops will run only those times. So we are running it 3 times. So it is like uh, 3n, but 3 we ignore. It will be big of O of n. So if you like this video, please do like, share, and subscribe to my channel, and put your valuable comments on it. What you have liked, what I can improve on that. Yeah, thank you.